Sorry, but I wanted to record you. Is that all right?
Yeah, that's good.
Okay.
So, and the reason we're using Mylar is because it's airtight, so it'll protect the dust from being contaminated, and it's also very, very strong compared to many like plastics, if you want to use, and it can survive the extreme temperatures of space. Well, that's for the Mylar we do want. This is what we're using right now. What we want to use is gold-coated Mylar, which is currently used on satellites in space to protect them from the intense heat and cold. And that one's even stronger than this stand-in material, and it's still airtight, and it's collapsible. It can crumble, and it can still maintain its structure. So that would make it a good inner airtight layer.
So the way that the bag works is most of the Mylar is completely sealed up, but you need to have the gap, and the gap is closed by magnets. I can't really see it.
Yeah, it's difficult.
It's hard to see, but we have the magnets here. This is basically just magnetic tape, and it's long strips that we use to line the bag and seal shut.
So the way we want to open this is we'll have one hand here, and this is just would be attached to the spacesuit somewhere. So when you pull, if you were to pull this away, it would create a second point of tension, allowing you to open the bag with one hand. And you would use the other one to hold the duster.
And it allows you to easily put it back in the bag. Since you're only using one hand to open it, you can use the other one to stuff it in and then close it. And the tension of it, and since it's clipped to you, it'll keep it by your side. It won't float away.
Yeah, it's attached to you, and it's all in one piece. So it is pretty easy to use. We have tested it, and we have a video of that.
Yes. We're going to share that to you now. That was the video.
I want to explain the handle real quickly more. So it is in currently 3 parts to bend, and we want to eventually make it out of something that is more durable and a lot stronger than 3D print. But as for now, we have printed it in SolidWorks just so we have a quick prototype. And the same with the handles. We're going to eventually change the handles so that they're less blocky and easier to use. And we're just trying to make it easier to use for the astronaut with the gloves while also being smaller and more compact. Currently, as you told us, we were looking for a second way to seal the bag because we aren't sure if the magnets work yet.
We aren't sure how well they work. And maybe even like a stronger magnet strip might even help us with sealing the second layer. Any questions so far?
Okay. So, are you done?
Yeah.
Okay. So let's. So that seems like it's really a one-time use thing.
No. You can, all the parts in here can be taken out, reused. The bag is reopenable, reclosable. It's not throw away after once used. All you have to do is swap out the Swiffer handle, and you can go back to space and use it again.
Okay. So, so what I think would be helpful is that, okay, so both your handles don't need to be the same, right? Because you're really, the one side that's got the clip on it, it can be completely different than the bigger side that's going to be grabbed by a glove, right? So I would think about what would be a better way there. I would also think about using individual stronger magnets versus strip magnets to squeeze it together. Okay. I also would think about trying to make the handle self-collapsing, because on the video you had to grab where you just collected dust with one glove, which is going to knock stuff off of it, okay, versus have something that will be easier to retract or self-retracting, right? So it doesn't have to bend. It could be telescopic, okay? So another thing I would think about is making the Mylar a bag that goes in and out with it, so that when you come back in, then you could pull the Mylar bag out with it. You could pull the handle out of it. You could then seal the Mylar bag and send the Mylar bag down to Earth. Okay? So that every time an astronaut went out, if they're on their EVA, if they had an opportunity to collect stuff, and I would even put on the outside of the Mylar bag a place to write the location where it was picked up, where things were dusted, or other data like that. Does that make sense?
Yeah.
Okay. So, because once you get, once you get the handle up there and the big bag up there, what will go back and forth from Earth would be just the lightweight bag with the lightweight, duster in it. And then I think what you want to do is you want to take a duster which has some dust on it, and you want to show how you're going to get the dust off of it. Right? So when you're back on Earth, how are you going to capture the dust from the thing? And do those things put some kind of oil or scent on it, which could contaminate? I mean, I know that's a commercial off-the-shelf type thing. And so you need to kind of look and see what are they putting anything on that fabric that might contaminate that dust? And if the answer to that yes, then what you need to say is you're going to build your own.
All right. Thank you.
Yeah, thank you.
You're welcome.
Yeah, that was great suggestions. I made a whole bunch of them. Some of them very similar this morning. Like with the dust, I said, make a colorful dust so that when you test it, we can see that dust that you collect. Because I wasn't so sure about how the dust would shake off of the
right. So I mean, the white dust on the black tabletop, you saw that it collected it.
Yeah,
right?
Yeah.
But now, if you were to now shake that, would the dust just fall off of it? Right? And down here, we'd put it in some type of glove box probably to shake it off, to try to collect it. But chances are it just doesn't shake off.
Yeah. But sealing the Mylar bag, the innermost bag, so that's all they need to do is they seal the bag, and then they put on a new bag into that system, with the new duster.
Right.
And that would be easy. They could collect a whole bunch. It could be reusable a lot of times. And I love the idea of labeling it. We need to know where it came from. So just use a material. I like that you sewed also, guys. That's pretty cool.
That is.
If Glenn was here, he'd love that. He loves when you sew.
Right.
But I also really like your suggestion. I was making suggestions about the handles, but I like that they don't have to be even. That Stacy said. That is so true. So thank you.
So who plays ice hockey?
This was these were from a previous project years back.
Oh, okay.
So yeah, Fairport's been in extreme science, and I saw Donna there.
Oh yeah, it was Donna.
Yeah.
Hello.
Hi.
Nice to see you. Thank you for spending time with our kids today.
Yeah, we're both here.
Yeah.
Our pleasure.
I've been playing cameraman. It was me moving the camera around for you guys.
But that's important. I love visiting with the kids. So they came on early at 7, and we just continually talked. And I told them not to show their PowerPoint because they had just explained it to you, showing their
Sure.
model. They had such a good model.
No, absolutely.
So good job,
Absolutely.
guys.
Very good job.
Thank you
All
to
right.
you both.
Thank you.
All right. Now you can listen. They're going to listen to the other groups. And
Flo, are
so-
you gonna send out that video when?
I'm
later?
recording right now.
Okay, wonderful.
Yeah, I am recording. And now Billings Career Center is going to present. Hello, Billings.
Hello.
Hey.
Able to hear us?
Hello.
Is it all right if I record you?
Yeah.
Yeah.
Totally fine.
Okay.
Hey, how are we sounding?
Good. You're sounding
All right.
tremendous.
Okay,
Good.
All right. Okay, so my name is Noah Clark.
I'm Zachary Glossop,
And I'm Aaron Keller.
and we are working on the lunar dust collector. So far, we only have a 3D model or 3D printed model of what we plan on doing, but we do have further intentions of extending off of this. We also do have a presentation to demonstrate our progress in the project so far. So,
Yeah.
You guys want to start the presentation?
Yeah.
Yeah.
Just put it up. Just. Okay.
all right.
Can you guys see the presentation now?
Yes,
Yes.
perfect.
Okay.
All right.
Okay, so our goal is to just build and design a product for the necessary task, which is the lunar dust collector.
And we are doing so abiding by the constraints that were demonstrated to our group. We are utilizing the Project Lead the Way design process. The definition of the problem is NASA needs to collect dust on the exterior of the International Space Station. And we also follow the constraints provided that it must be compact, it must be easy to use in microgravity, and it cannot cannot experience contamination between different environments.
Okay, so our journaling consisted of introducing the problem, and then we went through the design process and figured out what steps we were going to take to design said solution. And then we included some questions that will be answered in the future on how we're going to better our design and give our solution to NASA. So, okay, so we individually generated concepts to start off. We first went through docs and used ideas to basically just build off of each other. And first we started with what could be possible, what isn't possible, what are negatives of it, basically breaking down what's possible for it.
And then we moved into group brainstorming, and we informed all of our individual ideas into one solid idea that we can hopefully make a reality.
Okay. Are you guys ready to go back to the video?
I think we have a few more slides, yeah.
Yeah.
So those are just better close-ups of what our individual brainstorming was.
Mm-hmm.
So you want to?
So this is like basic kind of at the start where we were like designing and we were kind of like making a model and like what we want to see it. And so I wrote like a lot of notes of like how I want to see this made and like examples of how it would look. Like as you see on the right, like a hitch on this. It didn't print on this one, but it'll have it, and it should attach to
They
the.
can't see the video. They're not seeing it.
Yeah.
Oh, okay.
Just, yeah.
So our ideas basically consisted of a paint roller with silicone around it. We first thought of the last group's idea with a bag and a roller, a sticky roller, but we realized that it's not reusable to the point where we want it. So silicone allows us to be able to scrape off the dust and figure it out and put it into a controlled environment, basically, for collection.
These are just more of the along the way ideas that we had. The one on the left conform more to the paint roller idea, kind of like the one in the middle. It's just a double-sided paint roller. And the one on the right is the one that really took off on or started the current design that we have. So we started out by designing the handle. The image on the left is a working drawing of what our current handle design looks like. The middle picture was a failed print because we printed the handle too large. The one on the right is more of a good idea and a good size for our handle idea. We ended up making the one on the right side a little bit bigger, and we turned that more into our storage, which we'll explain a little bit later. So on the left side is the idea for the roller. It's going to be held in the left hand of the astronaut, and the tip is going to roll on its own, probably through a ball joint or bearing joint, and it has threads up more by the handle.
Did you freeze?
Did we lose you?
Because of the design, it's solid and it will be able to withstand the pressure differences from the exterior of the space station.
Okay, so we lost you for about 20 seconds.
Yeah, we lost them totally now.
Yeah.
Here you come.
Let me get back to your video.
Yeah, we lost you. We lost you about a half a minute ago.
Oh, that's no good.
Yeah, that's
Okay, you had talked about the handle, and you had just come up with the inner part of your handle and how it was going to be a bearing.
Oh, yep. So
pick up after bearing.
Okay, so that's kind of where we move into our physical product. So the left side of the handle is so this bottom part is gonna be held by the astronaut, which can be done.
Yeah, if you want to bring that up here and show that on this,
Yep.
so they can see it close up. Let's switch cameras so you can talk
All
about
right, yeah.
it. Great.
So we're gonna do a more close-up demonstration.
Should we show them the print first?
Okay, so this is what you got there. Or this.
Okay.
So it's going to be held in either the left hand or the right hand of the astronaut, and it can be done so with the bulky gloves. And it's going to unthread from the top of the device, and the smaller part is going to be kind of like a silicone roller, like a lint roller, and it can thread back into the left side handle. So yeah. Yeah, and on the bottom of the left side here, we are planning on adding a clip that can be used to keep it attached to the astronaut's spacesuit. But when 3D printing, it did not print correctly onto here, so we would have to add that later on down the road with a more finalized model.
Okay.
That about wraps it up for our demonstration. So
Okay, so is it a friction? How do those two pieces stay together?
So we are planning on underneath this bulky part of the handle, there are supposed to be threads, but they didn't 3D print correctly. And on the inside of the stores, there's going to be threads that match up. So when the astronaut goes to put it back together, it'll thread together and create that airtight seal.
Okay. So what I want you to take a look at is a water bottle threading system. What you're going to find is it's a multi-thread, and so you don't have to turn it very far before. And multi-threads have a kind of a locking function as well. All right. So it shouldn't be just a single thread. It should be, multiple threads. So look at your drink bottles, your plastic throwaway bottles, and see how those are done. And you probably want to do something similar to that. Okay.
Mm-hmm.
That current design, that handle looks kind of small to grab in that glove.
Oh, this part right here, the end part?
Yeah.
Yeah, we didn't get to print it out the way we wanted. We wanted to
Okay.
be in the exact same shape.
Yeah.
The
Good.
basically it's a rounded triangle.
Good. I like that. I think that's a good plan.
Yep.
And so now you've so it's a one-time thing unless you have something that you're going to wrap around the collection in and then take that off, right?
Yeah.
So you might think about how you can make that reusable.
Yep, that was within our intentions, but we were under a time constraint, so we kind of just had to put something with our ideas together.
Sure, and it could be as simple as, well, it's a thin-walled tube that slides on that, right? That's got some sticky things on it that will collect the dust, and then you can take that off. You could have something that holds that on. It could be just a friction fit, or it could be a nut or something at the end, right, that locks that on. But think about making it reusable in some way or fashion, some form or fashion. Flo, what do you got?
So my first question actually is for you, Stacy. If we show something can hold water, does that mean it's could hold air also? So here's a toy that holds water perfectly, and
Sure.
and because we need to somehow prove that it's sealed enough to hold the air, right? So here's another one. Here without water, but it just opens, it's hinged, and it closes by magnets.
Right. That's interesting.
And it
So,
holds water perfectly. I could throw this thing in, it would still hold the water.
okay.
But I don't know if that proves, I mean, water molecules are a lot smaller than, are a lot bigger than air molecules, right? So I don't
Sure.
know. How do we
So,
prove that it
are we
holds
talking
air?
about dust?
Yeah, the dust.
The
No,
dust.
we're talking about the air because they want it to be a vacuum. They don't want the dust to be exposed to the air of the space station.
Okay. So where does that fall in on this?
So when they collect the dust and they're gonna take it inside the space station,
right?
they don't want any air to get into their bag or whatever they're used to collect the dust.
Okay. So okay. So they don't want
no air.
They don't want any air to
be in that container where the dust is, because as Glenn said, there are ways that we have collected dust, the cosmic dust, but that's always been exposed to the air. This is cosmic dust that we don't want exposed to any air. We want it in a vacuum.
Okay. So
It's, these things just close by magnets. They're little magnets placed around it.
right. That's but still, at some point, it has to be open, right?
Yep.
So,
but when they open it, they want it as pristine as possible.
Right. So, what I would do is if that's what I was trying to do, is I would then have a sleeve insert inside the device that when you're outside, the sleeve stays in it. You're outside, you collect this stuff. But then what you want to be able to do is you want to be able to disconnect the handle and close the sleeve and then pull the sleeve out with the rod on it. Does that make sense?
Yes, it does.
Yeah.
So the part that has the particles is never exposed to the air in the station, but the end of it will be exposed to some air, right? The end that connects to the handle would. So what you need to have is you need to have some kind of button that releases the handle from the wand, and that then exposes. So you need to think about how you're going to fit a sleeve inside that thing, and then fold it up or over or however that's going to fold. But whether it's a Ziploc,
yeah, that's what I was thinking. Even
or this magnetic system, right? I don't know, but water is pretty slippery.
Yeah, it is.
You know, so I would have a tendency to think, but you're going to have issues with magnets on space station. I'm just going to tell you that it's hard to get magnets approved to go on space station because we don't want magnets interfering with our computers. So we typically don't allow a lot of magnets,
especially strong ones.
That is understandable.
Does that make sense?
Yep. Yeah. And that would make it reusable too. So my other thing, and Stacy, you're probably familiar with this. This is no residue.
Okay.
I used to call it NASA tape because we used it all the time on Ellington Field, and they had rolls and rolls of it because they don't want to leave a residue.
Sure, that's the flight tape. Yeah.
Yeah, and it's made by 3M, but it has a very sticky surface. What do you think of something, compare this to the regular tape that leaves a residue? Wouldn't this be much better because it doesn't leave a residue and maybe the dust would come off easier?
So the question, I don't know. The question is the chemicals in that tape going to affect the dust?
Right.
And without a residue, then that means that, well, it's not going to affect the equipment on the outside. It means if you ran it across the solar panel, then it shouldn't affect that solar panel, right? Because it's not going to leave anything on it.
Right.
But the question is, the stuff that it sticks to it, what is it going to do to that stuff? And that's what the question, that's what every group that's that's doing this solar dust collection has to ask themselves, and that is, how is the media that I'm using to grab the dust going to affect the dust itself?
Mhm.
Right? It'd be like, well, if I had a thermometer that had more mass than the individual I'm trying to take temperature of, is my thermometer going to change the temperature of the subject versus the subject change the temperature of the thermometer?
Mhm.
And so we don't want to affect the dust. We want to collect the dust without affecting the dust.
Right. And how would you get the dust off the sticky material?
Right, right. And maybe that's a different chemical, but you don't know. I don't know. I don't know what it takes to get the dust off the tape.
Right. And maybe there is a sticky material out there. You got to do research that maybe would work to do
Right,
that.
right. No, absolutely. But you've done a lot of great work. I'm very, very pleased with everything you've put into it. I've thrown a couple ideas out there. That doesn't mean you have to do my ideas. That just mean, think about how you would do it. If you want to use those ideas I threw out, that's fine. But don't think that that's the only way to solve this problem.
Yeah. And I loved your engineering book, and also your respect for brainstorming. You had everybody's brainstorming. So that's good teamwork, cooperation, and keeping good records in that engineering book are all very important aspects to being a great engineer. And this, Stacy, is a Project Lead the Way aerospace engineering class.
Oh, good. Very good.
So I will come and visit you. I'm not traveling, I don't think, this month. But thank you. And you can always send questions. Keep asking questions. That's real important.
Will do.
Did you have any other questions?
So about questions. So I saw something like online. It said like infrared. It can like see cosmic space dust, like infrared light. When you like shine on it, you can see cosmic space dust. Is like that true?
Boy, I don't know.
I don't know
Stacy?
if that's true or not. Let's send that to Glenn.
But would there be a way that we can use like some sort of light to see where like the most buildup is? So maybe we can get a large like amount and like, because I feel like you guys would want a larger amount of cosmic space dust.
Yeah. So I think that's a great idea. Well, ask Glenn about the light. All right. You know how to send him an email. Copy me. I need to know the answer too. And that would be a smart approach. Find out where on the space station, because we're on the outside of the space station. We don't know where the cosmic dust collects, if it collects. So that would be really a great ask. It's kind of an add-on, but that's really an important part of this project if we're going to collect cosmic dust. So I like that approach. Nice job.
That is good. That's a great question.
Yeah. Any other question?
I don't think so. I think that's it.
Okay. All right. And when you send Glenn that, send him the link that you read it on.
All right.
So he can read it and see if it's a good link or not. Because you can find all kinds of things on the internet. And for Mr. Anderson, the voice went perfectly. We practiced yesterday, all kinds of things, but I could hear each of you really well. It was perfect. So thank you.
Okay, and they'll have to send me their question like we've been doing, and I'll forward it to you and Glenn then. So that
yes, that's perfect.
Forward it back to them just because of the blockers on their school.
Yeah,
account.
and I do have one other suggestion, guys. When you 3D print tooth parts, make them different colors. so we could see the color going in and out instead of all pink.
All right.
Okay, you guys have a wonderful afternoon. We have another team, but they're not coming until 10 o'clock. They're on the West Coast in Olympia, Washington. So I'm
Okay.
gonna drop off, and I'll be back. Stacy, can you come again at 10 o'clock?
You mean 11 o'clock my time?
11 o'clock your time.
Yeah, absolutely.
Awesome.
I'll see you at 11.
Okay. Thank you all so much.
All right.
Bye-bye.
Bye-bye, y'all.
Thanks, Stacy. Bye-bye.